Okay, yesterday we found the zeros from a polynomial function. Today, given the zeros, you're going to write the polynomial function. So for example 1, we're going to write a polynomial function f that has rational coefficients, a leading coefficient of 1, and has the indicated zeros. Okay, we're going to go ahead and do it, and then we'll go back to the directions and see what they're talking about. The first thing they're telling me is that this is called function f, so I'm going to go ahead and call this f of x. Okay, they're giving me the answers or the zeros. So if a 0 was 5, then the factor must have been x minus 5, because when I solve that, I'll get an answer of positive 5. For the 0 to be negative 3, the factor must have been x plus 3. Now they want my polynomial to have rational coefficients and a leading coefficient of 1. So I'm going to multiply this out so I can get a polynomial in standard form. This is x squared plus 3x. You can also box this if you prefer that method. Minus 5x minus 15. Okay, so I got f of x equals x squared minus 2x minus 15. This is my answer. Let's go back to the directions to make sure we met all the requirements. Okay, the polynomial function is f. Got it. Rational coefficients. The coefficients are 1, negative 2, and negative 15, which are all rational. The leading coefficient is 1. This is a 1x squared, and it has the indicated 0, so that's my answer. Okay, so I've done everything I need to do. Let's go ahead and do the next one. Okay, this one is still called f of x. The zeros are negative 2, so x plus 2, positive 1, so x minus 1, and also positive 7, so x minus 7. Okay, I'm going to multiply this out so I can get some rational coefficients leading blah, blah, blah. Now, when we multiply them, remember we can multiply them in any order we would like to, as long as we hit everything. If two of them happen to look easier, I would do them first, but I'll just start here. And if you like to do it on the side, that's also fine with me. Okay, let me do this. This is x squared minus 1x plus 2x minus 2. I'm going to go ahead and simplify that. X squared plus 1x minus 2. And then let me bring down all the rest of this stuff. And I'm still needing to times it by x minus 7. Okay, so now I'm going to go ahead and distribute this part of it because I still want it to be in standard form so I can have the coefficients. So I'm going to go this way. 1, 2, 1, 2, and so on. You could do it a different way. I do this with x cubed minus 7x squared plus 1x squared minus 7x minus 2x positive 14. Okay, and since this was 3 terms times 2 terms, I should have 6. 1, 2, 3, 4, 5, 6. So I think I got them all. Let me look for like terms, and I'll write my polynomial. X cubed minus 6x squared, negative 7 minus 9x, plus 14. And just like the first one, I called it f. It has rational coefficients because the coefficients are 1, negative 6, negative 9, and 14. And the leading coefficient is a 1 because it's x cubed. So that's my answer. Okay, now we're going to get to a fun theorem. Okay, before we do, we're going to talk about conjugate pairs. Conjugate pairs are answers that normally come together. For example, when we solve, we often get like 5 plus or minus 2i, or we get plus or minus answers a lot. Okay, the part that is plus or minus is normally the radical part, which is this, this, and this. We call them conjugate pairs, which means if 5 plus root 11 is an answer, normally 5 minus root 11 is also an answer. If we get negative 3 plus 7i, negative 3 minus 7i is also an answer. And if I get negative 2 minus 5 root 3, negative 2 plus 5 root 3 is also an answer. Just the radical part changes signs. They come pairs, positive, negative, positive, negative, negative, positive. Okay, the irrational conjugates theorem says if a polynomial has rational coefficients, then irrational zeros come in conjugate pairs, which means if 2i is one of my answers, negative 2i is also one of my answers. If I get root 7, negative root 7 is also my answer. Or if I get something like 3 plus root 2, then 3 minus root 2 is also my answer. Okay, so we're going to do the same idea, but now we're going to keep this in mind. So this says, write a polynomial function f that has rational coefficients, leading coefficient of 1 and has the indicated 0. So same directions as the above. Okay, they tell me the zeros are 3 and root 5. So let me go ahead and start writing this. F of x equals, to get positive 3, it must have been x minus 3. Now to get root 5, it must have been x minus root 5, which is a fairly ugly polynomial, but that's okay. But because it's a irrational answer, if positive root 5 is an answer, then negative root 5 is also an answer automatically. Even though they don't tell it to me, I know they come in pairs, so I have to do both, which means x plus root 5 is a third 0. Okay, now I'm going to multiply this out. Okay, and these look like they're going to be terrible to multiply out, but if you multiply the conjugates together, they end up coming out nicely every time. So we do that part first. Okay, I'm going to do this on the side, and then I'm going to write the answer. Okay, if I would distribute this and this, I'm going to erase this in a second. I get x squared plus root 5x, and then I'm going to get minus root 5x, and then I'm going to get minus root 5 times root 5 is root 25. Okay, these cancel. So I end up with x squared minus the square root of 25 is just 5. Okay, so the nice thing about conjugates is when you multiply them, they come out nicely. It's a difference of squares. The shortcut, it would have been x times x is x squared. Since this is a minus and a plus, I know the middle terms are going to cancel. And then negative root 5 times positive root 5 is negative square root of 25, which goes back to 5. Now I just have to distribute this part. Okay, so x times x squared, x cubed minus 5x squared. I'm going to distribute the minus 3. Minus 3x squared minus, no, plus 15. Hold on, that doesn't look right, does it? X cubed minus 5x, so I messed up there. It should have just been 5x. Okay, let me check. Minus 3x squared, positive 15. Okay, this looks good, but I am going to rewrite it in standard form. X cubed minus 3x squared minus 5x and positive 15. Okay, and this does have a leading coefficient of 1, and then it has all rational coefficients. Okay, let's try B. Okay, the zeros are 0. What is 0? Yeah, you can write x minus 0, but x minus 0 is just x, so I'm just going to go ahead and put an x here. If it's negative 4i, it must be x plus 4i. But because I is a radical, if negative 4i is one of my answers, then positive 4i is another one of my answers. So I'm going to add x minus 4i. And I just know this because of the theorem from above. Okay, let me distribute this out. Now I'm going to multiply the conjugate pairs first because I know they're going to come out nicely. Okay, x times x is x squared. I know the middle terms are going to cancel, so I'm going to do positive 4i times negative 4i, so I'm going to get negative 16i squared, which isn't bad at all. Okay, let me fix this because I know I cannot leave I squared in my answer. If I do negative 16 times negative 1, it's going to switch it to a positive 16. And then let me go ahead and distribute this. X cubed plus 16x, and that's a nice answer, and it's in standard form. Okay, go ahead and try the practice problems. Pause the video, unpause when you're ready to check. Okay, here's number 1. Okay, number 2. Okay, and then there is number 3.